Noodles, what are you doing? What's going on? Ha! I get it. Nice job, Noodles. I'm just so proud that she's already learning corny math puns. Okay, welcome to adding and subtracting rational numbers. And maybe you're thinking, just what the heck is a rational number anyways? So let's try and clear that up. A rational number is any number that can be written as a ratio, think fraction, of two integers. In fact, when you look at the word rational number, the word ratio is in there. It's because a rational number is any number that we can write as a ratio. For example, 1/2, that's a rational number. It's the ratio 1 to 2. But the whole number, 15, that's also a rational number because we can write it as the ratio 15 to 1. Let's think a little more about that. And we're going to draw a diagram in this space below. I want you to start out by drawing a small circle, smallish, in the middle. This circle is the whole numbers. These are the numbers that you worked with all through elementary school. They're numbers like 0, 5, 92, or maybe 8 million. These are the whole numbers. Beginning with some of our work in 6th grade and then now continuing in 7th grade, we've started to talk about a different set of numbers. Draw a circle around the whole numbers. We're doing it around the whole numbers because this works kind of like a Venn diagram. All of the things inside this circle fit into this category. This category is the integers. Label them. Integers are all of the whole numbers inside, and then all of their negative opposites. So for example, -5, it's the opposite of 5. -92, it's the opposite of 92. And -8 million, it's the opposite of the whole number 8 million. But there's a whole class of numbers that doesn't fit in here. And you're probably like, yeah, I know, fractions, decimals, percents, oh my. That's great. Let's draw a circle around that integer circle because just like the last one, everything inside this circle fits into this category. And now let's label this circle the rational numbers. Or, if you want to be clever, the rational numbers. It's not really that clever, but ratio is in that word. Okay, and so the rational numbers are all the whole numbers, all of the integers, and then there's numbers like 1/2, or -3/4, or 0.49 repeating, or maybe 3 5/7, or maybe -3 5/7. All of these are rational numbers, and that's what we're going to work with computing next. Now, you might be wondering, this is kind of like a Venn diagram where everything inside the circles where they overlap, those all fit in. And you might be wondering, what about outside the rational numbers? And that's great because there are definitely some numbers outside the rational numbers. In fact, you've probably already spent some time with them. So one example is this guy, pi. And another example is this, the square root of 2. And there's other numbers that are not rational numbers, they are irrational numbers. And we'll talk more about them later. But for now, understand that we're working with all of these numbers. And the cool thing about rational numbers is we don't have to change our understanding of math. We can still use the same rules that we've been working with so far. Let me show you what I mean. Let's do some work together. So on the top, we've got some integer problems, and then below, we've got some nice rational number problems. Let's start with the integer problem first. -6 plus 4. Now hopefully you're getting real fluent with this type of question. These are two numbers with different signs, which means we need to subtract. And I know that -6 has larger absolute value, so that means this is going to be a negative, And when I subtract, the difference is 2, so the answer is negative 2. Okay, now let's look at the problem below. Negative 6.5 plus 4 2/3. This is a very similar question. In fact, the numbers are not so different at all. So we should already identify that this is going to end up being a negative number because they have different signs. We've got to subtract. And the negative number, negative 6.5, is a larger absolute value. Okay, so we're already partway there. In fact, we have a pretty good estimate of what would be a reasonable answer for this. It should be close to negative 2, or somewhere in the neighborhood of negative 2, because all we did was add some fractions for this problem. Okay, so now let's compute. So I have different signs, I've got to subtract. Now's where I got to remember all of that great work that I did with fractions. So 6.5 minus 4 2/3. You could convert these into improper fractions. Sometimes it's easier though if you leave them as mixed numbers and go this way. So I'm going to find a common denominator. The common denominator is 6. Multiply the top and the bottom by 3, which means 1/2 is 3/6. And 2/3, multiply the top and the bottom by 2, get 4/6. And since 4/6, I need to take that away from 3/6, I have to borrow from this whole number, which means I'm going to take one whole all the way over here. And so 6/6, it's going to end up being 9/6. That's what that new fraction is. And 9/6 minus 4/6 is 5/6. And I'm not done yet because I've still got to subtract the wholes. 5 minus 4 is 1. Now, side note, if that fraction computation was challenging for you, that's totally okay. Totally fine. But what I want you to do is make sure that you watch the refresher video on adding and subtracting fractions, because that's going to help you get up to speed with it. And we'll do some more practice in class. Okay, so the answer here is 1 5/6. Oh, wait, it's negative 1 5/6, because negative 6.5 has a larger absolute value. All right, let's do a different problem. Negative 3 minus negative 7. Okay, this looks kind of intimidating at first, but we remember that when we've got subtraction, it's the same as adding the opposite. So negative 3, we keep. We change subtraction into addition, and we change negative 7 to its opposite, 7. And now we just have two numbers with different signs, so we have to subtract. And I know that it's going to be a positive because 7 has a larger absolute value. This is positive 4. Okay, and now the rational number problem with some decimals. This again should give us a number that's close to 4, because when we keep, change, and change, we get a problem that's very similar to the one that we just did. Only difference is we've got some decimals. This has a larger absolute value, the 7.843, so we know it's going to be positive. And I have two numbers with different signs, so I'm going to subtract. And now all I need to do is do some side work to do this subtraction. 7.843 minus 3.54. Got to add some placeholder zeros. And now I'm going to do the subtraction like normal. Don't forget that decimal. And the solution is 4.303. Close to my integer problem. In fact, one strategy that you can always use with these types of problems is to round the rational number to the nearest integer, compute that sum or difference, and then check to make sure the answer you actually got is close to it. That's how you know that you are on the right track. Okay, so you're ready for some practice. I want you to pause the video and then try the problems on the next page on your own. If you need to, you can check along with me once you have finished.
It's all done.
Alright, here we go. First question. It is got some rational numbers and I'm freaking out because I see fractions, I see negatives. So first thing I'm going to do is I'm going to remember that these are just numbers and I can still apply the same rules that I did with integers. I can keep the first number, change subtraction, and change the second number into the opposite. So if I rewrite that, it's negative 4 3/5 plus negative 1 3/4. Okay, now I'm still a little uncomfortable, so I'm going to do some estimation. I'll do that over to the side. -4 3/5, well, that's kind of close to -5. I'm going to call that -5. -1 3/4, that's kind of close to -2. -5 plus -2, well, so that's -7, which means my answer should be somewhere in the neighborhood of -7. And I remember that if I've got the same sign, I've got to find the sum and keep the sign. Okay, so now let's actually find the real sum. 4 3/5 plus 1 3/4. Again, you could use improper fractions here. That might be more efficient sometimes. Here, though, I think is one where it's going to still be efficient to use mixed numbers. So I'm going to convert these into fractions with the denominator of 20. Multiply the bottom by 4, the denominator by 4, and the numerator by 4, which means I get 12/20. Multiply here the denominator by 5 and the numerator by 5, which means I get 15/20. And now I'm going to add these together. 12 plus 15 is 27/20, and 4 plus 1 is 5. And I'm not done quite yet because 27/20, I don't like that. I need to change that into a new mixed number. 20 goes into 27 one whole time, and then there's 7 left over. 1 and 7/20. And then if I put 5 together with 1 and 7/20, these two things are going to combine to make 6 and 7/20. Okay, and so that means my final answer over here is 6 and 7/20. And don't forget the sign. It's a negative because I have two numbers that are negative that I'm adding. Okay, let's take a look at the next one. -8.1 plus 0.439. So here, I've got two numbers with different signs. So I'm going to need to subtract. And if I look at the numbers, it's going to be -8.1. That's close to -8. And here, I'm going to estimate here. So that's close to -8. And 0.439, well, that's closer to 0, but let's just, for the sake of estimating, let's call that 1. And -8 plus 1, well, that's 7. So, -7. So my final answer should be somewhere around -7. We'll see. Okay, so I know I need to subtract these two. I know it's going to be a negative because 8.1 has a larger absolute value. So now all that's left is for me to set up the subtraction. I line up the decimals. Add some placeholder zeros in. Ooh, and I have to regroup. It's not my favorite thing, but I'll do it because I have to. Which means my final solution is -7.661, which is close to what we estimated. Good job! You're ready for some practice. Nice work. Noodles is impressed too.